A nuclear rocket by 2027. Witnesses claim there's a UAP cover-up, and there could be trillions of rogue planets wandering the Milky Way. All this and more in this week's Space Bites. Nuclear rockets are not a new thing. Scientists have been testing out this idea for decades and proven that it works. All you gotta do is connect up a fission reactor to some kind of propellant, usually like liquid hydrogen. You run the fission reactor, it gets super hot, then you superheat this propellant like hydrogen, and it blasts out the back of the rocket at extremely high velocities. And the performance of these nuclear rockets is really impressive. If you had a spacecraft that was powered with a nuclear rocket, it could significantly shorten the flight times to other worlds. You could do Mars in 90 days, which is down from almost a year with chemical rockets. So there's lots of upsides to developing nuclear rockets. But there are downsides, and that's the main reason why we haven't seen them actually get implemented. People are concerned. What happens if you try to launch a nuclear reactor into space and it fails? Well, I mean, there have been many nuclear reactors launched into space. The Soviets launched dozens of them. The Americans launched one. Not to mention, you've got all of the nuclear RTGs. These are, of course, the chunks of plutonium that are used to power the spacecraft that are too far away from the sun to use solar power. There's RTGs on the Voyagers. There's RTGs on the Perseverance and Curiosity rovers and many other missions out there. So this issue of launching a nuclear reactor into space has been somewhat addressed. But because of the potential performance capabilities of these nuclear reactors, NASA and DARPA are getting pretty serious about actually testing one of these in space. And this week we learned that they have set a plan, they've provided funding, they've chosen Lockheed Martin to develop a nuclear reactor spacecraft, and they're hoping to actually test one by 2027. So the plan is to put the reactor on a more traditional chemical rocket and launch it into space. It'll be launched cold. But then when it reaches an altitude of 700 to 2,000 kilometers, they'll turn it on and actually test out the capability of the nuclear rocket. There's a couple of questions. What is the behavior of this uranium fuel when it is in low Earth orbit? When it's exposed to the vacuum of space, when it's exposed to microgravity, what happens with cosmic rays hitting it? Like, there's a lot of issues with being in space, and the ground tests aren't going to teach you that. Probably the biggest unsolved issue is how to keep your hydrogen propellant stable in the vacuum of space. It's a very tricky fuel to work with. People haven't been able to make it last longer than a couple of months in space before it just boils off. And so one of the big challenges is going to be to figure out a way to keep your cold cryogenic propellant stable for long periods of time so that you can use it with your nuclear reactor. Developing a long-term cryogenic storage for propellants would be impressive and would have value not just for nuclear rockets, but really for any refueling proposals where you would keep your fuel in space and have rockets be able to dock, fill up their fuel tanks, and continue on to space. And so if they're able to crack that problem, it would have huge benefit, whether or not they figure out how to get the nuclear rockets rolling. Yeah, I think that's the thing that I'm most excited about. It's about developing refueling in space, because I feel that's what unlocks a lot of our exploration of space. I mean, nuclear rockets would be cool too, though. All right, on to the UAPs, because I know a lot of people are interested in this topic. So this week we got a House subcommittee meeting hearing on UAPs. So we had 3 former insiders give testimony on the UAP encounters that they've had. 2 were military pilots. 1 was an intelligence agent who said that there's plenty of evidence that the government is hiding UFOs, UAPs, both in terms of the crashed spacecraft as well as even crashed aliens. The testimony that we heard this week, we've heard this before, unidentified objects moving in ways that seem to violate the laws of physics, things that are hovering. One of the most interesting claims was that the government is hiding non-human biological remains. Obviously, we have to parse that very carefully. What does that mean? Non-human biological material is currently in the hands of government officials. Obviously, this is the kind of thing, this kind of claim that would need to be investigated. So unfortunately, we didn't get any evidence. We didn't get any examples of this non-human biological material that astrobiologists could study. We didn't see hardware. We didn't get a chance to see the actual spacecraft, the crashed material, debris, so that material scientists can study it, aerospace engineers can take a look at it and verify that this is beyond the laws of physics as they understand them. And the testimony that was made runs counter to what was said by the Pentagon's own subcommittee hearing back in April, where Sean Kirkpatrick said there's no credible evidence that they've found for anything that violates the known laws of physics. So, more questions than answers. No actual evidence was brought forth. And hopefully, if anyone has anything that they're hiding, they'll bring it forward and put it in the hands of scientists so they can study it. There could be trillions of rogue planets in the Milky Way. Rogue planets are planets that don't have stars, and they have been discovered just wandering around in the Milky Way. It's possible that they were ejected out of existing star systems. It's possible that they formed in place out of small amounts of gas and dust, enough to just form a planet without getting the full star. But whatever the case, we know that there are a lot of them. They've been discovered using this technique called gravitational microlensing, where you watch as the light from a star briefly changes as an object passes in front of it. It's being lensed by what is an invisible object, a planet. We can't see it, but its gravity forms enough of a lens that it can distort the light from the star. A new study suggests that there could be 20 rogue planets for every star in the Milky Way. So this means that there are trillions of rogue planets moving around the Milky Way. And this is really exciting because when we think about what it'll take to do interstellar travel, you've got to go from here to the nearest star system that is like 4+ light years away. But if there are in fact hundreds of rogue planets in between us and the nearest stars, the distances that are involved are dramatically lower. And back to that idea of refueling. You could go to a rogue planet that's just say 1/10 of a light year away, refuel everything, and then move on to the next one and use them as stepping stones to get across the Milky Way. We've just got a hint that there are a lot of these rogue planets now, so we're waiting on next generation telescopes like the Nancy Grace Roman, which launches in just a few years from now. That will give us a much better understanding of just how many of these rogue planets there are in the Milky Way and where they came from. An enormous cosmological simulation wraps up. One of the powerful tools that astronomers use to understand the universe is cosmological simulations, where they take all of the observations of the universe as we see it today, and then they run various simulations, changing the amounts of dark matter, dark energy, neutrinos, regular matter, and see how the universe evolves over time. Each one of these simulations uses more and more computer power, includes more and more of the factors that may have a role in the influence of the universe. And so the latest simulation to wrap up is called Millennium TNG. They simulated regular matter, dark matter, neutrinos, dark energy over billions of years of the universe's evolution. And they ran the simulation on 120,000 computer cores. They tracked 100 million galaxies in a 2.4 billion light year volume of space. And like the goal of this is to search for cracks in the cosmological model. Like astronomers know that they don't have a complete picture for how the universe evolves over time. How did supermassive black holes get so big so early? What is dark matter? What role does dark energy play? How do you explain the crisis in cosmology where the expansion rate of the universe seems to have changed over time? Why do some galaxies have no dark matter while others are all dark matter? And what does the future hold for the universe as we move forward into time? And so these enormous simulations help show where our misunderstandings might be and the best places to point big telescopes like James Webb. A galaxy with no dark matter. Speaking of strange mysteries and cracks in the cosmological model, astronomers have found another example of a galaxy that seems to have almost no dark matter in it. Typically, galaxies are seen, and thanks to the gravitational lensing, astronomers are able to see that the galaxies have about 85% dark matter and then 15% regular matter. But that's an average. And so you can see galaxies that have more dark matter, ones that have less dark matter. And in some very rare cases, you find galaxies that are all dark matter, or galaxies that have almost no dark matter. And this is one of those examples. And the galaxy is relatively close and fairly well known. It's called NGC 1277, and it's located about 240 million light years away. And according to the study, scientists say that it has about 5% dark matter. And one of the other interesting characteristics of this galaxy is that it has a surprisingly massive supermassive black hole. It has 17 billion solar masses, which is more than 4,000 times more massive than the supermassive black hole that's at the heart of the Milky Way. Does this overly massive, supermassive black hole somehow account for the lack of dark matter in the galaxy? When we find other galaxies that have less dark matter in them, will we find that their supermassive black holes are more massive than we expect? It's an interesting finding and shows some possible trends to look at. There are some really impressive telescopes coming online shortly, like ESA's Euclid mission, as well as the Nancy Grace Roman telescope, as well as the Vera Rubin Observatory, which will be able to find and categorize more of the dark universe, finding where the dark matter is and where it isn't, and what role dark energy is playing over its evolution. So stay tuned. We're just at the very beginning of starting to understand this. Every week we do a vote on all of the stories that we covered and give you a chance to tell us what you thought was the best story. And last week, the winning vote was this story about whether the universe could be twice as old, won by a landslide. So thank you everyone who voted last week. And of course, we'll put up a vote shortly for this week so you can tell us which of the stories you thought was the most interesting. We're also doing a special vote because of our new 1-year anniversary episode on the James Webb Space Telescope. We've got all of the best images out of James Webb, and we're putting them head to head. You can vote, tell us what you thought was the best picture, and we'll talk about the results shortly. And if you haven't already watched it, you should definitely check out our 1-year retrospective on all of the discoveries and findings from the James Webb Space Telescope, all of the pretty pictures, all of the interesting science that was done. And it really kind of puts everything that was discovered in that first year in perspective. We're really proud of it. And so if you haven't already had a chance to watch it, you definitely should. And so make sure that you are subscribed to the channel to get notifications in the community tab when we put up these polls so you can vote and participate. Thanks. Speaking of amazing pictures coming from the James Webb Space Telescope, here is a picture of 2 young stars orbiting around each other in a binary system. You can't make it out, but there is a protostellar disk that the stars are orbiting around. And each time that they crash into this disk of gas and dust, the stars will throw out another jet of material. And then as these jets of material crash into the previous ejected material, it heats up, and so it becomes visible in the infrared spectrum. But the part that's more amazing about this picture is the surrounding blue glow. And anyone who's done any astrophotography, this is known as a Bok globule. And when you see examples of Bok globules in the visible light, they are just these black blobs. They are completely opaque to visible light. And yet, in the view of JWST, the globule is gone. And you can see down into the stars forming in the middle of the nebula. This is probably the most concrete example that I've ever seen of something that I am very familiar with. I've taken pictures of these. I've seen many examples of them. And to have it just be turned invisible, it's like X-ray vision, although it's infrared vision. Anyway, it's amazing. So here's an example of 2 stars that are forming, and once they fully ignite, once their fusion is really rolling, they're going to blast away all of this material with the radiation, and then they will just be stars, like all of the others that we see out there. A new technique to figure out what the Milky Way is made of. It's always tricky to figure out the Milky Way because we are trapped inside of it. And so any view that we want to have about the spiral arms of the Milky Way is obscured by the spiral arms of the Milky Way. It's very hard to see the outside of your house when you're inside of it. So astronomers used a new technique called chemical mapping or chemical cartography to try to get a sense of the structure of the Milky Way. They tracked the metallicity, or sort of the amount of metal in the stars in a region about 30,000 light years away from the sun. And then they applied statistically the metallicity that they found there to the other regions of the Milky Way that they can't make out that metallicity. And from that, they were able to identify which regions of the stars in the sky were due to the spiral arms and get a better sense of where the spiral arms are in our perspective. And so you can imagine, as this technique gets better and better, we could eventually get a very realistic map of what the Milky Way looks like, even though we are embedded right in the middle of it. There's no way we could ever send a spacecraft far enough to look down on the Milky Way from above. I had a chance to interview one of the patrons recently. I don't normally mention this, but actually I send out an email to every new person who becomes a patron if they want to do an interview with me personally. Tell us what we're doing right, what we're doing wrong, how we can make things better, what are the topics that you're most interested in, and you have a chance to ask me any questions that you might have about space astronomy or how we run universe today. And it was interesting. The patron told me that they felt very happy as soon as they had subscribed as a patron, that they'd gotten so much value out of what we do, all of the reporting, all of the videos, all the podcasts, and not being a patron made them feel a little anxious. And when they became a patron, made them feel happy. And that's perfect, right? That we're able to provide this service and it makes people happy. I couldn't ask for anything more. So if you want to be happy, go to patreon.com/universe today. Happiness not guaranteed. A gamma ray burst set off detectors twice. There are a few causes of gamma ray bursts. The short gamma ray bursts seem to come from colliding neutron stars, kilonova. The long gamma ray bursts come from supernova, giant stars that collapse, form a black hole, detonate as a supernova, and give off this blast of radiation that lasts for hundreds of seconds. Now, astronomers have found a gamma ray burst that lasted 1,000 seconds. It's not the longest, but it's one of the longest. But what's really interesting about it is that the amount of radiation coming from the burst had two peaks. Normally you get this one peak right at the beginning and then it fades away. But in this case, it got two peaks. And in fact, the two peaks were so bright separately that they set off the detector of a spacecraft twice. It initially thought that it was seeing two separate gamma ray bursts, but in fact, it was just the one. So what caused this? Now, there's a bunch of ideas, but one that I find really exciting is that it could have been due to a gravitational lens that was imaging the gamma ray burst as it was going off. And so you got the initial light from the explosion, and then you got this flash, this lens flare coming from the lens as it lined up and showed the gamma ray burst. If that's true, that would be amazing. But chances are it's something a little more mundane. Maybe the blast hit a nearby star and that caused the second flash. So astronomers still aren't sure why it got this double blast. I'll keep you posted. I'll talk a little bit more about the UAP testimony in a second, but first I'd like to thank Joel Yancey, Antonio Lofilara, Dustin Cable, Just Paul Davis, Vlad Chiplin, Jay Dennis, David Giltanan, Modso, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verboff, Andrew Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us. It's always tricky when we have these kinds of allegations, and I'm not sure how to describe it, because I'm interested in space and trying to figure out what's out there in the universe, and UAPs, we don't know that they have anything to do with space. So should we report on them? And I know people expect, or people just assume that it's aliens, but there's no positive evidence that there's anything that has anything to do with aliens. If we had evidence of aliens, it would be the most profound discovery in all of human history, I think. Yes. And so you want to be sure, right? You want just amazing evidence that tells you that this thing is true, because if it is true, then we would need to change our entire society to deal with the possibility, to deal with the repercussions of being in a galaxy that is bustling with other civilizations. And that requires changes in policy, technology, in incentives, just our entire everything. And like, what amount of evidence would it take to begin that process of preparing ourselves for being part of a galactic civilization? And I think like people get mad at me because I'm not convinced, because I don't see adequate evidence that this is true, that there's anything that we need to take very seriously yet. And like I was waiting, I was really hoping, like this is it. This is the week. People told me this is disclosure, right? We get to see aliens. We get to see the bodies. We get to see the spacecraft, but we didn't. So will we see it next time? Will we ever see it? Yeah, I don't find the evidence compelling yet. And I report on it because, man, because people want it to be compelling. I don't know. Anyway, this is where it gets ranty. So, I'll let you know when they find aliens. I will be the first to tell you when they find aliens. I can't wait for someone to find aliens.